Anyway, whilst we're waiting for Tim, I'll explain what the 3D printer does and how it works. What we've got here is reels of filament, and this filament, we've got this machine prints in two materials. We've got ABS plastic, which you find a lot of things made out of. It's a thermosetting plastic, so once you heat it up and melt it, it's solid. We've also got a support material, which is polyvinyl alcohol, or PVA. You probably use PVA glue at school. It's the great stuff. You put it on your fingers, you can peel it off.
Yeah.
PVA, when it's dried out, you can heat it and then it will work much like a plastic. But the great thing is PVA is water soluble, so we can dump it in this bath, which is about 70 degrees centigrade, and you see it just flopping around there, and it will dissolve by using motion of water. So what we've got here is the ability to build using solid material, but also build support material. So for example, if you had an overhang, something overhanging, normally you'd be printing up in layers. Problem is, this is kind of just suspended there. So we build up a build-up layer as well, so that we can support this, because you can't just start printing in mid-air. So this machine can handle the two. What it does to start off with, it lays a base layer known as support. And so you've got this plate here. You can print up to the size of a plate, up to about that deep, so quite a size. So the first thing it does, it puts this support layer down, and the idea about it is to make sure if there's any imperfections in the bed, it's perfectly flat, so it's always printing onto a perfectly flat surface. At which point it will then start laying down the build material on top, and then it just builds it up, slices it layer by layer by layer by layer. Now, the reason this is useful here, because we've got SolidWorks here, you can export what's known as an STL file. And the STL files, or stereolithography, is just a collection of triangles which build up a three-dimensional object, at which point, and Tim will show you by running it through, we can take the SolidWorks model you made today, export it as an STL file, then import it into the 3D print software, at which point it slices it into lots of little bits. That looks like a towing hitch from a car.
No, it's a bit to stick here. It's an adapter piece for a sat-nav thing that goes on the windscreen in your car.
It's close.
So that's what you've just created, yeah?
Yeah.
When this decides to wake up.
So the stuff you were looking at earlier, all those different models and things,
yeah.
you could just get the file exported in.
Yeah, whatever you want. Whatever you want,
yeah.
You can stick it through. I put a plate in there, Tim. I can tell you where to place the model if you want. It's a scrap plate.
Yeah, so there it is. What I'll do is I'll go File, Save As. STL, we'll call it.
Cool. Tim, you're still not there.
The file type is different.
Yeah, you were typing. I'm going to change the file types in.
Yeah.
What you called it? Timo?
Yeah. So there it is. Change it, see it all into triangles.
It's a lot of triangles.
The reason for that is just a very efficient way of describing a three-dimensional model.
So I'll go File, Open STL.
Probably the graphics, isn't it?
Much cheaper, yeah, processing-wise.
I'll go and find Timo down there. There it is.
The software is not normally this slow. The computer's having a bad day.
It is having a bad
It's because it's being shown to other people. Otherwise, it would be
3 days of showing the same thing.
I've got 8 gig of RAM in here as well.
You think it would operate a bit faster.
Oh no, think it's been wanting to do Windows updates, Tim, that's why.
Is it?
Yeah,
It's throwing up a hissy fit until it gets it.
pretty much.
I hate it when it updates it for you and you keep going, no, I don't want to update it, I don't want to update it. And it goes, oh, I'm updating it, and then I'm going to restart it for you.
There we go, hooray.
So it's in now. Alright, as you can see, you know, this area here is the area of that plate.
Yeah.
Yeah. I don't want to print a big one. Yeah. I'm just going to print a little one. What I can do is I hit auto orientate. Yeah. Which slings it round onto a decent plane. I change the scale to 0.25.
Quarter scale.
Yeah. So that's a quarter scale now. I'll go add to pack. So this is now packing it somewhere on there. I'll go pack.
Right hand diameter.
Okay, what I'm going to do is I'm going to delete that, remove that.
Right hand diameter, third square left, bottom. So down at the bottom, the right hand side of that circle, touching the third line on the right.
What about there?
No, two more across. Yeah, there, down a touch. That's a down a touch, a bit more to the bottom of the screen. Bottom of the screen, Tim. There you go, that's clear space on the board.
Okay, so I'll go print now.
So what it's doing now is just sliced it up into layers. It's just transferred the model over to...
You video recording.
Well, I'm video recording everything. I have like a blog I have about stuff like this.
Yeah.
So
Screwdriver, Tim?
basically all this is just about the 3D printing and stuff you told us about earlier.
Right, so what we've got in there, we've got a plate which has got a special coating on it, and that coating is activated by heat, so the environment is kept at 77 degrees centigrade to activate the coating. This makes the base stick. So what it's doing now, the plate is coming up and down, it's going through photo interrupters at the top and the bottom, and this makes sure that it's zeroed the plate. It knows exactly where it is in 3 dimensions, so this is calibration at the moment. What you'll find now, it will then come out, this top head, it's pressed a lever over there which has dropped a calibration sensor. It's now going to do a touch on in multiple places on this plate, make sure it's flat. If it finds anywhere that the plate isn't flat, it can then recalibrate itself, so when it prints the base lines on, it will be able to then make sure that its surface it's printing on is flat. So it takes a little while to calibrate, so it's got quite a lot of error checking to do.
So how long does it take, once it's all set up, how long would it take?
20 minutes for this.
Yeah, for this size model, 20 minutes. But it depends on the size of the model, the complexity as
So
well.
if we go back to a screen here, and we can look at our orientation, printer status, you can see that it's built this model using 40 layers. The material used is model material 2.134, support material 0.809. Add those together about 3. Yeah, it's cost about 60 pence to make that. If I go back to our orientation, and we'll have a look at this. If I go to the bottom, we can see the individual layers.
So this is the first layer it's going to print, and because you can tell it's blue, so it's going to be the support material. So what it's going to do now, it's going to take about 2 minutes just to get the extrusion temperature up. To extrude ABS, you're talking, there's 3 temperatures. There's a holding temperature,